Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video we solved question number 4 related with exercise number 5.1 relevant with the topic equation of the particular curve that has a slope given at the particular point. In today's video I am going to solve the next question number 5 and question number 6 with which exercise number 5.1 will be completed. This is related with chapter number 5 integration FSC part 2 mathematics. This question number 5 and question number 6, this is related with the same topic that we already learned in the previous video. So let's move toward question number 5 of exercise 5.1 chapter 5 integration class FSC part 2 mathematics. It tells that a certain curve has a slope x into 2x square minus 1 whole square that passes through the point 3, 3. What is the equation of the specific curve? In the previous video we already learned that the slope is actually represented by small m, which is equal to dy by dx. We already learned in detail in the previous video that dy by dx is actually called slope. Derivative of function y with respect to x is actually equal to the slope, which is equal to x into 2x square minus 1 whole square. So dy by dx is actually x into 2x square minus 1 whole square. Shift dx on the right hand side, it will multiply with x into 2x square minus 1 whole square. Now take the integral sign on the both sides. So integral of dy, you know that it is always equal to y. Now over here, let's suppose I assume 2x square minus 1 is equal to t. Derivative both sides with respect to x. So derivative of 2x square will be 4x and 1 is a constant, its derivative is 0. And over here it become dt by dx. dt by dx will be equal to 2x square derivative is 4x and 1 derivative is 0. After this we will shift dx on the right hand side, it becomes dt is equal to 4x dx. Now over here we need with x dx, so we will align x dx by dividing both sides with 4, so it becomes dt by 4 will be equal to x dx. Now it becomes integral dy will be equal to x dx is dt by 4 and 2x square minus 1 we suppose it t, so it becomes t square dt by 4. Now after this integral of dy is actually y, because if we differentiate y with respect to y, it again gives a 1. After this, our t square the integration will be, we will add 1 in the power, it become t power 3, and we will write the same 3 in the denominator, and we will multiply with 4 in the denominator, it become t power 3 by 12. So t power 3 by 12 and plus constant of integration. Now t is not actually the original variable is x, so replace t with 2x square minus 1, so it becomes 2x square minus 1 whole power 3 by 12. This is the equation, but over here we need with the value of c. How can we calculate value of c? We will just put the point through, it passes through the point 3, 3, so put y3 and x3, so put y3 over here, x3 over here. By simplification it will give us the value of c is equal to minus 4877 by 12. Putting the value of c over here, this will be actually the required the equation of the specific curve. Now move to the next part of part number 5. It tells that a certain curve has a slope x into square root of 2x square minus 1 that passes through the point 3, 3. What is the equation of specific curve? So the slope is actually derivative of the function y with respect to x, which is equal to x into square root of 2x square minus 1. Shift dx on the right hand side, it becomes dy will be equal to x square root of 2x square minus 1 into dx. Integrate both sides. So it becomes integral dy is equal to integral of right past of 2x square minus 1 square root, and after this write x into dx. So why I write x dx combined? Because over here we need x dx. So over here let's suppose 2x square minus 1 is equal to t square. Differentiate both sides with respect to dx. So 2x square derivative with respect to dx is 4x. 1 is a constant, its derivative is 0. And t square derivative is 2t. Now t is an inner function, so we will write dt by dx. Shift dx on this side, it becomes 4x dx, and 2t dt will come down as it is. 2 cancel out with 4, we left with t dt is equal to 2x dx. Now over here we need the value of x dx, so divide both sides with a 2. So on this side we left with x dx is equal to, and on this side we left with t dt by 2. Now putting the values in this integral, so integral of dy will be equal to integral 2x square minus 1 we suppose t square. So it become under root of 2x square minus 1 we suppose t square, so it become under root t square. X dx is t dt by 2. Now integral of dy is y. After this a square will cancel out with under root, we left with t, and t dt by 2 will come down as it is. T into t will give us t square dt by 2. Now the t square integration is actually add 1 in the power, it become t power 3, and write the same 3 in the denominator. But over here we have 2 in the division, so we will multiply, so 3 multiplied 2 gives us 6. Now t is not actually our original variable. Our original variable on the right hand side, our independent variable is x. So replace t with over here t square is equal to 2x square minus 1. So take under root on the both sides. So the value of t is under root of 2x square minus 1. So put under root 2x square minus 1 over here. It become under root 2x square minus 1 whole power 3 by 6 plus c. Now this is not the required equation. Over here we need the value of c. For finding the value of c, we will put the value of x3 and the value of y3 in this equation. So the required value of c will be minus 8.68. By putting the value of c over here, you will get the required equation. So this is actually the required equation for the specific curve. So with this question, exercise number 5.1 is completed. Inshallah, in the next video I will solve exercise number 5.3, and I skipped exercise 5.2 because 5.2 exercise I already solved. In the description I will give the link, and I will give the link in the description of this video, so you can watch all the videos of this chapter number 5 by clicking on the list for the playlist of chapter number 5 integration. So thank you for watching, subscribe my channel, and also hit the bell icon to receive the upcoming notification about FSC part 2 mathematics. Thank you.